Hi, Assalamualaikum. My name is Noorshida binti AZIZ. So today our group will talk about the complex that we have choose for our assignments. So after the reaction between the copper perchlorate with the phenanthroline in the acetone, the complex that has formed is bisphenanthroline perchlorate copper 2 ion. The complex consists of combination 1 copper 2 cation, 2 molecules of phenanthroline and 1 perchlorate anion. So the formula for this complex is copper phenanthroline 2 perchlorate with the net charge plus 1. And we can determine the structure of the complex by drawing, which is like this. There are three types of complex, which is anionic, cationic and also neutral. But we consider our complex is cationic complex because the net charge of this complex is positive 1. The combination number of the central metal is 5 because we have 2 molecules of phenanthroline, which is bidentate ligand, consists of 2 donors atom for each of molecules, and we have 1 perchlorate anion, which is monodentate ligand. So the total numbers of the donors atom is 5, and we consider the coordination number for the central metal is 5. The geometry shape of this complex is trigonal bipyramidal because it has 5 ligands. The trigonal bipyramidal have axial and equatorial positions. Trigonal bipyramidal also have 19 and also 120 bond angles.
In order to calculate the oxidation state of copper in the complex, firstly, you have to know the oxidation state of each ligand in the complex. Next, substitute each value of oxidation state of ligand in the equation, which will equal to positive 1. And then solve the equation and you will get the value of copper's oxidation state is equal to positive 2. In previous question, we had mentioned about ligand's oxidation state. But what is ligand? Ligand is the number of molecules that surround the central metal. In this complex, there are 2 ligands, which is phenanthroline and perchlorate ion. There are 3 types of bonding, which is monodentate, bidentate, and polydentate. Perchlorate ion will form monodentate bond to a central metal, while phenanthroline will form bidentate bond to a central metal. In detail, perchlorate ion will form monodentate bond at O atom, while phenanthroline will form bidentate bond at N atom. This complex is unstable. Why it is unstable? Because after calculation, there are 37 numbers of electrons which do not follow to EAN rule.
Okay, hi, Assalamualaikum warahmatullahi wabarakatuh. And it's my turn to continue the explanation. Okay, my name is Muhammad Amir Muzzaffar bin MUSA. My metric number is D201810831002. Okay, my part is about the electronic transition in compound complex. Metal complexes often have spectacular color caused by electronic transition induced by the absorption of light. The DD electron transition are allowed in complex in the center of symmetry. It means that when the light is absorbed, so the compound will transmit the color. The color we will see, the color that we see in the compound is the complementary of color. So we know the difference of color transmits the difference of the wavelength. Some of the color spectrum that the compounds will absorb. For example, we have violet, indigo, blue, green, yellow, orange and red. The wavelength with the long wavelength is the red, is between 620 to 720 nanometer, while the shorter wavelength is the violet color, is about 400 to 420 nanometer. Okay, why does a transition metal complex appear to have a color, it is because it absorbs light at a specific wavelength in a visible region of electronic spectrum. Okay, for bis 110 phenanthroline perchloride copper ion is a non-octahedral complex. It is trigonal bipyramidal. It is because of the distorted. Its removal one ligand, so it's become trigonal bipyramidal. The color of the complex is occurs by exciting of the electrons from the lower energy to the higher energy. It absorbs the color and transmit a higher energy. From the graph of the spectrum of bis 110 phenanthroline perchloride copper 2 ion, the consideration of the orbital energy splitting scheme for a ligand of a trigonal bipyramidal symmetry, one should indicate that a D9 ion should give it rise to absorption of wavelength due to the transition dx2 yx2 dxy to dz square. Moreover, the high energy transition should lie on a somewhat below the corresponding octahedral complex with similar ligands. Okay, that's all from me. Thank you.
Hi, Assalamualaikum. My name is NURFARAHIN TASHNI binti RADZALI. I will continue about valence bond theory. In this part, I choose valence bond theory to discuss. So first, we need to calculate the oxidation number of copper. We know the proton number of copper is 29, so the oxidation number of copper is +2. Next, we need to draw the electron configuration of copper, which is argon 4s2 3d9, but for copper +2 is argon 3d9. Next, we calculate the number of electron donor. In this part, for ClO4, we need to multiply by 2 electron, so it have 8 electron of donor. Next, we draw the 4s and 4p orbital, so it look like on the slide. In conclusion, the hybrid orbital of the complex is sp3d, and the geometry shape is trigonal bipyramidal. The complex ion has 1 unpaired electron in 3d orbital, so its complex is paramagnetic. The complex is known as high spin complex and spin free complex.